master's focused on deep learning, and I did it, like I mentioned, I started it while I was part-time while I was full-time at Uber. Loved my role at Uber, wasn't ready to leave, was learning a ton through working there. And in my time at Columbia deciding to do research, I looked around for programs that would interest me and professors who had research groups with openings. And this Smart Cities group led by Dr. Kostic in the electrical engineering department.
Yes, this did come up a bit in our research. Yeah, this is awesome. Yeah, keep going, keep going.
Yeah, so this Smart Cities research group funded by NSF had a component related to self-driving cars. And I thought, this is amazing. I love learning from my Uber colleagues. We have a whole autonomous group. So I can have this whole extra set of experts to pull in as I'm learning with this Columbia academic community. So joined that research group. And what's kind of funny is a big part of the value I added early on was just good software engineering practices, reducing the chaos. You did a PhD. I'm not sure if this resonates with your experience, but even now, I was at a AMS conference on climate forecasting recently and talking to somebody from NOAA about technology. And he said, the research is really hard to wrangle. This Columbia research group was not at the level of NOAA, and it was a mix of graduates and undergraduates and postgrads. And so working on just version control and shareability and reproducibility was pretty big first focus, but from there, really digging in on the problems. I mentioned wanting to work on the vehicle aspect of self-driving, and the group had just put cameras on 2 buildings at the corner of 120th and Amsterdam on Columbia's campus. And so there was new data coming out of that, and what data person doesn't love new data? So we were thinking about the problem to solve there. It's how can you use image data from multiple cameras to detect vehicles and pedestrians moving through an intersection, ideally with the end result of making traffic flow more efficient, which is climate positive, as well as making people safer. And started with needing to map the images from both cameras into one plane that overlap with one another, so one homography. And then from there, running object detection and tracking models on each image stream individually. And so I was working with a group on that, and we published some research about whether this quite distant bird's eye view of an intersection is useful image data for these types of models. We weren't building custom models at that point. It was kind of taking the best in class in the late 2010s. So that was the YOLO v3, YOLO v4 times, like SDS, a few other options. And unsurprisingly, pedestrians were very challenging to detect and track. Cars were a little easier, trucks a little easier. And one of the biggest problems with pedestrians, they lose their shape from that distance, but they're also easier to block from other objects. And so a truck would go by and you'd lose visual on a person walking, or a tree would have leaves and you wouldn't see a person behind that. And that, to me, was a really big opportunity for the multi-camera setup, where one camera might not have an occlusion blocking important objects that we want to track, and the other camera might. So being able to select the right camera for your detection at the time was the space I zoomed in on. So kind of building a set of meta learners to determine which camera's images you want to use for a prediction at any given point in time, and a sub-algorithm that split the image up into a bunch of different grids and choosing for each component of each image grid which camera is best suited, and then stitching those images back together. And if you could stitch that whole image back together and then only run inference once, you've still got a real-time model that has a chance at being part of a real-time system in the city. So that was a lot of fun for me, and didn't end up doing as much with the self-driving team at Uber as I'd hoped. They work a lot with LiDAR data, which in my research, anytime you're reading about multiple cameras, you're reading about stereography, and LiDAR is so much better than image data in that space. And so if I could have convinced the city of New York to go LiDAR with all of these devices, that would have been worth it. But I'm such a pragmatist. I knew that cameras are a lot cheaper. And so I wanted to know what we could do with image data.